Imagine a future where humanity is not confined to a single world, but is a multiplanetary species. This isn't science fiction, it's the audacious vision driving SpaceX, and at its heart lies Starship. Every flight test is a monumental stride, a thrilling leap forward, but IFT-10, the 10th integrated flight test, represents a pivotal moment, a testament to relentless engineering evolution. It's not just a rocket, it's our future among the stars. Elon Musk's dream of Mars colonization isn't merely about landing a spacecraft, it's about establishing a self-sustaining city, a new civilization. Starship is the indispensable vehicle to make this a reality, designed to transport people and vast quantities of cargo. It's a fully reusable transportation system, unlike anything seen before. IFT-10 is specifically engineered to tackle some of the most formidable challenges remaining, bringing the dream tantalizingly closer. Why is IFT-10 so critically important? Because each test flight isn't just a launch, it's an invaluable data-gathering expedition. It pushes the boundaries, identifies weaknesses, and refines the design with astonishing speed. This 10th flight test builds on the immense learnings from its predecessors, targeting specific, crucial engineering evolutions that are absolutely vital for deep space missions. We're talking about perfecting the very essence of reliable space travel. Starship is a two-stage to-orbit behemoth, standing taller than any rocket ever built. The Super Heavy booster, its first stage, is a powerhouse of immense thrust, designed to return to Earth and be caught by the launch tower. The Starship second stage, the upper vehicle, is capable of orbital flight, re-entry, and landing not only on Earth but eventually on the Moon and Mars. This incredible synergy is what makes Starship so revolutionary, and IFT-10 truly puts it to the test. SpaceX's philosophy is simple: rapid iteration. Previous integrated flight tests, from the very first to IFT-9, provided invaluable lessons. Each flight revealed new insights into structural integrity, engine performance, stage separation, and even the nuances of re-entry. These tests, though sometimes ending in spectacular fashion, were never failures in learning. They were crucial steps, paving the way for the refined engineering we see in IFT-10. One of the most daunting challenges of spaceflight is atmospheric re-entry. The vehicle hurtles back into Earth's atmosphere at incredible speeds, generating immense friction and heat. Starship, with its unique stainless steel construction, relies on thousands of hexagonal heat shield tiles to protect its structure. For IFT-10, the focus on heat shield performance is paramount, pushing these tiles to their absolute limits and gathering critical data. These isn't your average ceramic. Starship's heat shield tiles are meticulously engineered from advanced ceramic composites, designed to ablate, or burn away sacrificially, carrying heat away from the underlying structure. IFT-10 incorporates crucial design refinements, improving attachment mechanisms and material composition to withstand higher temperatures and more prolonged exposure. Every single tile is a small marvel of thermal engineering, working in concert to save the ship. Earlier flights revealed specific areas where heat shield performance could be improved, particularly around leading edges, control surfaces, and tile gaps. For IFT-10, engineers have focused intensely on these hotspots. We're looking at reinforced designs, enhanced sealing, and new material blends precisely where the thermal stresses are highest. This isn't just about survival, it's about making re-entry so robust that it becomes routine, a crucial step for regular Mars missions. Starship's re-entry is famously unorthodox, the belly flop maneuver. Instead of coming in nose-first like a capsule, Starship performs a controlled horizontal descent, using its body as a massive air brake. This unique approach allows for maximum surface area to dissipate heat and slow down, but it demands incredible precision and atmospheric re-entry dynamics. IFT-10 aims to master this ballet of aerodynamics, crucial for precision landings anywhere. Central to the belly flop are Starship's 4 massive aerodynamic flaps. These aren't just decorative, they are actively controlled during re-entry to steer the vehicle with exquisite precision, much like a skydiver uses their body. IFT-10 is all about refining the control algorithms for these flaps, ensuring they can handle the intense aerodynamic forces and guide Starship to its precise landing zone, every single time. It's an engineering marvel in motion. The heart of re-entry dynamics lies in the guidance, navigation, and control, or GNC, systems. These sophisticated computers and sensors continuously calculate Starship's position, velocity, and orientation, making real-time adjustments to the flaps and eventually the engines. IFT-10 pushes the GNC system to new levels of autonomy and responsiveness, essential for navigating the unpredictable upper atmosphere and achieving pinpoint landings on distant worlds. It's incredibly complex. While Starship is performing its incredible atmospheric ballet, its giant partner, the Super Heavy booster, is on its own audacious journey back to Earth. This isn't just a controlled crash, it's a precisely choreographed propulsive landing, where the booster relights its engines to gently lower itself. IFT-10 aims to refine this ballet even further, targeting extreme accuracy for its ultimate recovery by the launch tower itself. This changes everything for rocket reusability. The Super Heavy booster isn't just landing, it's being caught. Imagine a towering skyscraper reaching out with giant robotic arms, aptly nicknamed chopsticks, to cradle a returning rocket. This revolutionary recovery method eliminates heavy landing legs and allows for rapid reuse, slashing costs, and turnaround times. IFT-10 is a crucial test for the precision required for this ambitious chopstick catch, proving the viability of this innovative approach. Guiding the massive Super Heavy booster back to the launch site involves another ingenious piece of engineering, the grid fins. These lattice-like structures deploy from the booster's upper section, acting like aerodynamic rudders to steer the immense rocket through the atmosphere with remarkable precision. For IFT-10, enhanced control algorithms and potentially refined fin designs are being tested to ensure the booster hits its target perfectly, ready for the chopsticks. At the heart of both Starship and Super Heavy are the groundbreaking Raptor engines. These full-flow staged combustion engines are immensely powerful, yet incredibly efficient. For the Super Heavy's precise landing, a select number of Raptors must reignite and throttle with extreme accuracy, decelerating the booster from supersonic speeds to a gentle touch. IFT-10 is a critical validation of this complex choreography of engine firings and throttling for ultimate reusability. IFT-10 isn't just about isolated improvements, it's about the synergistic evolution across the entire Starship and Super Heavy stack. Every component, from the structural welds to the avionics, has undergone continuous refinement. We're seeing materials tweaked, processes streamlined, and systems integrated tighter than ever before. This iterative design philosophy, a hallmark of SpaceX, ensures that each test flight builds on the last, accelerating progress towards Mars. The dream of Mars colonization extends beyond just SpaceX. It's an ambition that ignites the imagination of scientists, engineers, and enthusiasts worldwide. Successful reusability, particularly the heat shield and booster recovery, is the key that unlocks affordable, frequent access to space. IFT-10 isn't just a test for SpaceX, it's a test for humanity's collective aspiration to become a multiplanetary species. The stakes are truly immense, and the excitement is palpable. Days before IFT-10, the Starbase facility buzzes with activity. Teams meticulously perform an exhaustive series of pre-flight checkouts. Every sensor, every valve, every engine is thoroughly inspected and tested. These aren't just routine checks, they are critical safeguards, ensuring that all engineering evolutions are correctly implemented and functioning perfectly. The tension builds, but so does the confidence born from rigorous preparation. It's truly a spectacle of precision. As dawn breaks over Boca Chica, Texas, the colossal Starship and Super Heavy stack stand bathed in the golden light, a beacon of human ingenuity. The countdown commences, a symphony of technical checks and human anticipation. Each second brings us closer to ignition, closer to the moment where IFT-10 will prove its worth. The excitement is electric, a shared breath held across the globe. This isn't just a rocket, it's a symbol of what we can achieve. And then, the moment. A thunderous roar erupts as the Super Heavy's Raptor engines ignite, unleashing a staggering 7,500 tons of thrust. The ground trembles, the air vibrates, and Starship, our giant metallic marvel, slowly lifts off the pad. It's an awe-inspiring spectacle, a testament to raw power and human ambition. The engineering evolutions are now in motion as the rocket begins its incredible journey skyward. What an incredible sight! As Starship pierces the blue sky, accelerating with astonishing speed, every second is a critical data point. The flight trajectory, engine performance, and structural integrity are all meticulously monitored. This phase confirms the reliability of the Super Heavy booster's immense power, propelling Starship towards the edge of space. It's a flawless climb, a breathtaking ballet of physics and engineering working in perfect harmony. Absolutely incredible to witness. Then comes the audacious hot staging maneuver. At altitude, before Super Heavy's engines cut off, Starship's own Raptor engines ignite, pushing it away from the booster in a dazzling display of power. This maximizes efficiency and payload capacity. IFT-10's hot staging is executed with phenomenal precision, a testament to the refined control systems and the daring spirit of SpaceX. It's a key evolution for making Starship truly efficient. Immediately after separation, the Super Heavy booster begins its incredible journey back. It executes a flip maneuver, orienting itself for its return burn. A handful of Raptor engines reignite, precisely slowing its descent. This is where the refinements in GNC and engine throttling for IFT-10 truly shine, guiding this colossal stage towards its landing zone with unparalleled accuracy. We are witnessing rocket reusability taken to the next level. As Super Heavy rapidly descends, the launch tower's chopstick arms extend, poised for the catch. The booster performs its final, delicate maneuvers, guided by its grid fins and precise engine burns. This dance of precision, where a skyscraper-sized booster is caught mid-air, is the culmination of years of engineering. IFT-10's data provides invaluable feedback for perfecting this revolutionary recovery method, crucial for rapid reusability for Mars. Meanwhile, high above, Starship continues its ascent, inserting itself into a precise orbital trajectory. This isn't just a suborbital hop, it's a full-duration orbital flight, pushing Starship's systems to their absolute limits. The vehicle performs various tests in the vacuum of space, collecting vital data on its systems and demonstrating its readiness for the ultimate destination, Mars. Every moment in orbit is a profound testament to the engineering that built it. During its orbital cruise, Starship reaches peak altitude and velocity, simulating the conditions it would experience on a journey to Mars. This segment of the flight is critical for evaluating the vehicle's long-term performance in space, ensuring all systems, life support, power, communication, are functioning flawlessly. IFT-10 pushes these boundaries, gathering data that will inform every future deep space mission. This is where the engineering truly shines. After its orbital ballet, Starship reorients itself for the most challenging part of its mission, the fiery return to Earth. It begins its descent, slamming into the upper atmosphere at hypersonic speeds. This is where the upgraded heat shield tiles and refined re-entry dynamics of IFT-10 are put to the ultimate test. The air around the vehicle ionizes, creating a dazzling plasma sheath. The tension in mission control is palpable, as is the excitement. The heat shield tiles endure unimaginable temperatures, protecting Starship's stainless steel structure from incineration. For IFT-10, engineers are closely scrutinizing data from thousands of embedded sensors within these tiles, assessing their performance against the new material compositions and attachment methods. Every flicker, every hotspot, every successful deflection of heat is a triumph for the incredible engineering behind these tiny but mighty protectors. As Starship slows, its innovative belly flop maneuver takes full effect. The immense surface area acts as a giant air brake, shedding speed and heat. The four aerodynamic flaps, now fully articulated, actively guide the vehicle through the dense lower atmosphere. The GNC system is working overtime, making countless micro-adjustments to ensure Starship stays on its precise glide path. This is the ultimate test of controlled re-entry dynamics. At just thousands of feet above the landing pad, Starship performs its iconic, breathtaking flip maneuver. From its horizontal belly flop orientation, it quickly reorients to vertical, preparing for its final propulsive landing. This incredible feat of engineering is executed by powerful Raptor engines firing up almost instantaneously. IFT-10's refinement of this crucial maneuver is key to precise, repeatable landings, vital for establishing a Mars colony. With engines firing, Starship gently settles onto the landing pad, a magnificent testament to the engineering prowess honed over countless tests. The precision of this landing is nothing short of astounding, a direct result of the iterative improvements in GNC systems and engine control. This soft touch is not just impressive, it's absolutely essential for safely delivering future crews and delicate cargo to Mars and beyond. What an achievement! Immediately after landing, the work isn't over. Teams rush in to secure Starship and begin a meticulous post-flight analysis. Every sensor reading, every piece of telemetry, every visual observation is carefully scrutinized. The condition of the heat shield tiles, the wear on the flaps, the integrity of the structure, all provide invaluable data. This is how SpaceX learns, how they iterate, and how they push towards their ultimate goal, Mars. The performance of the heat shield is often the most critical outcome. Post-flight inspections reveal exactly how the new tile designs and attachment mechanisms performed under extreme re-entry conditions. Was the ablation consistent? Were there any unexpected hotspots? This detailed examination dictates the next round of engineering refinements, driving Starship closer to the reliability needed for human-rated missions to Mars. Every tile tells a story. The successful chopstick catch of the Super Heavy booster heralds a new era in rocket reusability. The ability to rapidly recover and refly the most expensive part of the rocket fundamentally changes the economics of space travel. IFT-10 validates the immense engineering effort behind this audacious recovery method, proving that what once seemed impossible is now a repeatable reality. This is an undeniable leap towards Mars. With the invaluable data from IFT-10 in hand, SpaceX engineers will immediately begin planning the next iterations. Even with remarkable successes, there are always refinements to be made. The journey to Mars is not a single leap, but a series of calculated, bold steps. Each flight builds confidence, refines technology, and paves the way for the missions that will one day carry humans to the Red Planet. The pace of innovation is simply astounding. IFT-10's engineering achievements, the robust heat shield performance, the refined re-entry dynamics, and the fully successful booster recovery bring Elon Musk's vision of Mars colonization closer than ever before. We are witnessing the birth of a new era, where interplanetary travel becomes not just possible, but potentially commonplace. The challenges are immense, but the dedication and ingenuity of SpaceX are proving that humanity is destined for the stars. What an incredible time to be alive! Beyond the incredible machines and complex algorithms, it's the human element that truly drives Starship's progress. Thousands of engineers, technicians, and visionaries pour their hearts and minds into this project, fueled by a shared passion for exploration. Their relentless problem-solving, their willingness to learn from every setback, and their unwavering belief in the Mars mission are what make Starship possible. It's a true testament to human ingenuity. Each successful Starship flight, and particularly the profound engineering strides of IFT-10, lays another brick in the foundation of a Martian future. It's about developing the infrastructure, the vehicles, and the knowledge required to not just visit, but to live and thrive on another planet. This isn't just space travel, it's species survival, a bold step towards ensuring humanity's long-term future. The scale of this endeavor is truly mind-boggling. While IFT-10 marks extraordinary progress, the path to Mars is still fraught with challenges. The unforgiving environment of space, the vast distances, and the complexities of human life support on another planet are monumental hurdles. Yet, with every Starship flight, humanity gathers more knowledge, develops more solutions, and builds more confidence. The spirit of exploration, fueled by hope and innovation, prevails. We are unstoppable. Starship is not just a rocket, it's an entire ecosystem of innovation. From advanced material science to cutting-edge software, from robotic manufacturing to complex logistical operations, every aspect of its development pushes technological boundaries. IFT-10's successes ripple through this entire ecosystem, proving the viability of technologies that will have applications far beyond Mars, benefiting humanity in countless ways here on Earth. It's a true technological marvel. Perhaps Starship's greatest impact is its ability to inspire. Watching IFT-10 ascend to the heavens, seeing its successful return, ignites a spark of wonder and ambition in countless young minds around the world. It shows them that audacious goals are achievable, that engineering can solve humanity's biggest challenges, and that the stars are truly within reach. This next generation will be the pioneers of Mars, thanks to these incredible efforts. When we consider Starship, and particularly the breakthroughs of IFT-10, we're not just looking at a rocket, we're looking at a shift in human consciousness. It fosters a planetary perspective, reminding us of our shared home and our collective destiny among the cosmos. The journey to Mars is a unifying force, transcending borders and uniting humanity in a grand, shared endeavor. It's truly a magnificent undertaking for all of us. Let's recap the evolution of re-entry. Early capsules faced extreme heat, relying on ablative shields for one-time use. The space shuttle had reusable tiles but was incredibly complex and delicate. Starship, with IFT-10's advancements, represents the next paradigm, a robust, fully reusable system designed for frequent, high-volume re-entries. It's a quantum leap in engineering, combining the best of both worlds for unprecedented reusability and safety. SpaceX revolutionized spaceflight with Falcon 9's reusable first stage, landing vertically. Super Heavy takes this to an entirely new level, not just landing but being caught by the launch tower. This difference is monumental. Falcon 9 requires legs and consumes fuel for deceleration, but Super Heavy's chopstick catch reduces mass, allows faster turnaround, and is designed for the sheer scale of Starship operations. IFT-10 proved this innovation. The sheer scale of Starship and Super Heavy presents unique engineering challenges. Building a rocket of this size, with its integrated reusability features, required rethinking materials, manufacturing processes, and ground infrastructure. IFT-10 showcased how SpaceX has mastered not just individual components, but the entire system at an unprecedented scale, making it robust and reliable. This is truly industrial-scale space travel being born before our eyes. When we talk about atmospheric re-entry, it's fascinating to compare Starship's belly flop to the Space Shuttle's winged glide. The shuttle, essentially a spaceplane, relied on massive wings and intricate thermal protection tiles across its entire surface. Starship, by contrast, uses its entire body as a brake, simplifying its structure while still achieving precise control with its flaps. IFT-10 validated Starship's elegant, efficient approach for routine re-entry. The speed at which SpaceX develops and tests Starship is unparalleled in aerospace history. This rapid iteration model, where lessons from one flight are integrated into the next vehicle in mere weeks or months, is fundamental to their success. IFT-10 is a direct product of this philosophy, showcasing how quickly engineering evolutions can be implemented and validated. It's a bold departure from traditional aerospace development cycles. For Mars colonization, Starship's heat shield needs to be incredibly durable, not just for Earth re-entry, but potentially for multiple entries into different planetary atmospheres. The data from IFT-10's heat shield performance is critical for understanding its long-term resilience and reusability. This test moves us closer to a heat shield robust enough to support repeated missions, ferrying vital supplies and people across the solar system, year after year. It's truly impressive. Automation plays an increasingly vital role in Starship's operation. From pre-flight checkouts to the complex sequence of re-entry and landing, automated systems handle countless critical tasks with precision and speed. IFT-10 further validated the reliability and sophistication of these autonomous systems, a necessity for missions where direct human control might be delayed or impossible, such as interplanetary flights. This is truly the future of space travel. While not directly tested in IFT-10, this flight sets the stage for future propellant transfer demonstrations, a crucial technology for Mars missions. Starship is designed to be refueled in Earth orbit, allowing it to carry maximum payload to the Red Planet. The reliability of Super Heavy and Starship's orbital performance, as demonstrated by IFT-10, are foundational steps towards perfecting this orbital refueling process. It's all connected to Mars. Starship's choice of stainless steel, rather than more exotic composites, was initially met with skepticism. However, its high strength-to-weight ratio at cryogenic temperatures, its weldability, and its heat resistance, especially when combined with the advanced heat shield tiles, have proven to be a game-changer. IFT-10 validated the structural integrity and thermal performance of this material under extreme conditions, cementing its place in spaceflight history. Amazing engineering. Elon Musk's timelines for Mars colonization are famously ambitious, often sparking debate. Yet, each successful Starship flight test, particularly the engineering milestones of IFT-10, demonstrates that these timelines, while challenging, are not impossible. They act as powerful motivators, driving the rapid innovation and relentless pace of development that defines SpaceX. This isn't just about reaching Mars, it's about doing it within our lifetime. Beyond the quest for Mars, Starship's full reusability, particularly the Super Heavy's successful recovery in IFT-10, has profound environmental implications. Reducing space junk, minimizing manufacturing waste, and drastically cutting down on single-use components aligns with a more sustainable approach to space exploration. This isn't just about going to Mars, it's about doing it responsibly, preserving Earth while we reach for the stars. It's a win-win for everyone. The Starbase facility in Boca Chica, Texas, is more than just a launch site, it's the crucible where the future of space exploration is being forged. From initial design to manufacturing, testing, and launch, the entire Starship development cycle happens here. IFT-10's success is a testament to the incredible infrastructure and dedicated teams at Starbase, truly making it the gateway to Mars. It's a beehive of innovation and activity. The success of Starship and the milestones of IFT-10 resonate across the entire global space industry. It pushes other nations and private companies to innovate faster, to think bigger, and to pursue more ambitious goals. This competition, fueled by SpaceX's audacity, accelerates humanity's progress in space, leading to breakthroughs that benefit everyone. It's a thrilling race to the future, and we're all winning. IFT-10 is a monumental achievement, yet it's just one more step in an epic journey. The road to Mars will be long, challenging, and undoubtedly filled with more lessons and triumphs. But with each successful flight, with every engineering evolution in heat shields, re-entry, and recovery, Starship proves its potential. It is not merely a rocket, it is a symbol of humanity's enduring spirit of exploration and our destiny among the stars. We're on our way. Even as IFT-10 concludes, engineers are already planning the next generation of Starship. Future iterations will focus on even greater reliability, increased payload capacity, advanced life support systems, and eventual crewed missions. The data from this flight informs every single one of those decisions, ensuring a continuous path of improvement. It's an endless cycle of innovation, always pushing the boundaries of what's possible, always looking ahead to Mars. The full reusability of Super Heavy, solidified by IFT-10's successful recovery, has profound economic implications. By making the most expensive part of the rocket reusable, launch costs plummet. This opens up entirely new markets for space, from deploying massive satellite constellations to enabling asteroid mining and, of course, making Mars colonization economically viable. It's a complete paradigm shift for the space economy. An exciting long-term vision for Starship involves in-orbit heat shield inspection and even potential repair. While IFT-10's focus was on Earth re-entry, the ultimate goal for Mars missions means the ability to repair or replace tiles after multiple deep space journeys. The data from this flight pushes the boundaries of understanding material fatigue and resilience, paving the way for future autonomous repair systems. The ingenuity is boundless. Starship IFT-10 stands as a shining beacon of progress, illuminating the path to an incredible future. The engineering evolutions in heat shield performance, atmospheric re-entry dynamics, and super heavy booster recovery were not just incremental steps, they were fundamental breakthroughs. They confirm that Elon Musk's grand vision for Mars colonization is not a distant fantasy, but a rapidly approaching reality. We are truly on the cusp of something extraordinary. While Mars is the immediate goal, Starship's capabilities extend far beyond the red planet. Its fully reusable design and immense payload capacity open up the entire solar system for exploration and settlement. Moons of Jupiter and Saturn, asteroid belts, even further reaches of space become accessible. IFT-10's breakthroughs are foundational for humanity to truly spread its presence throughout the cosmos. The possibilities are truly endless. What started as audacious concepts sketched on whiteboards has transformed into a tangible, powerful reality with Starship. The journey from initial designs to IFT-10's incredible performance is a testament to perseverance, ingenuity, and a refusal to accept limitations. Every bolt, every wire, every line of code contributes to this monumental achievement. It truly embodies the spirit of innovation, pushing the boundaries of what's possible. IFT-10's success in re-entry and landing greatly improves confidence in Starship's ability to safely deliver vast amounts of cargo. This isn't just about sending small probes, it's about transporting entire habitats, construction equipment, and life support systems to Mars. The precision demonstrated in this flight is vital for pinpoint cargo delivery, laying the groundwork for sustainable Martian outposts. It's foundational for future settlements. Ultimately, Starship is about people. It's about taking humanity to Mars, to live, to work, and to expand our civilization. The engineering milestones achieved in IFT-10, the survivability of re-entry, the reliability of landing, are direct steps towards ensuring the safety and comfort of future spacefarers. This isn't just a technical endeavor, it's a profoundly human one, driven by the innate desire to explore and expand our horizons. What an adventure! The 10th integrated flight test of Starship will undoubtedly be remembered as a defining moment in space history. Its achievements in heat shield technology, re-entry dynamics, and booster recovery haven't just advanced rocket science, they've redefined humanity's future. The vision of a multi-planetary civilization, once a distant dream, is now firmly within our grasp, thanks to the relentless pursuit of innovation. Thank you for joining us on this exhilarating journey.